Hi there and welcome to chandu.org. Right now I'm sitting in Melbourne, Australia, and it's a beautiful day here. And today I just wanted to share with you a really powerful technique for creating charts that tell the story of change. Many times when we communicate business information or analyze business data, the focus would often be on what has changed over a period of time. And many charts, for example line charts, scatter plots, bar charts, column charts, are often used to convey this kind of a picture. Today I want to show a technique with you which is a slightly customized scatter plot, and this is actually inspired from an article from Bloomberg. So first let me show you the original chart that was created by Bloomberg people, and then I'm going to show you a similar technique based in Excel. So this is how fast America changes its mind. It's the article. Naturally, the emphasis here is on how Americans change their mind with respect to various social or political issues. A good example is, for example, same-sex marriages. These are not usually accepted in social scenarios until few decades ago, but then around 2000, early 2000 years, various rulings and court cases were filed, and then eventually it became acceptable. And today, what was not acceptable few decades earlier is now accepted as a social norm across many states. So this article is trying to showcase that kind of a picture with respect to various issues where Americans have changed their mind, more like evolved, their perspective has changed over a period of time. And this chart depicts that kind of a picture. If you go down, and you would see that various issues. For example, we have the issue of interracial marriage, which was in 1787. It was not accepted in any states. I think the bottom is 0 states. And then you could see that once it was accepted in a few states, there was a stagnation for a period of time, but then the change is quite rapid in 1950 when interracial marriage became more acceptable, and it kind of peaked for all the states. Likewise, prohibition, which is consumption, which relates to consumption of alcoholic beverages, which is not allowed in 1800s, quite rapidly changed between 1900 and 1925 when during the First World War the prohibition was implemented, and then it was kind of repealed. A lot of issues, for example issue of abortion or issue of same-sex marriage, and now the latest issue being recreational marijuana, which is currently legal in 4 states of US. So you could see how with respect to some of the issues these things have changed. And if you go down, this kind of shows with respect to each issue how that issue became more like an acceptable thing in number of states, and how it has changed over a period of time. So this is the kind of interactive charts, animated charts they have created to tell the story of change. I think this one is really interesting. It shows all the things one at a time, and you could see the steeper a line is, the more rapid that change is accepted in all the states, and the outer boundary shows the number of states in the Union of United States. Remember, right now there are 50 states, but there were not always 50 states in US. Sometime back in, for example, 1800s, there were only 20 states. Probably some of the states got divided, and maybe US got hold of more land, and then they named those states. So that's how that expansion happened. So that gray line is showing the outer boundary for the change, and the green lines depict how many states have accepted that kind of a practice, and what would happen once it reaches a critical break-even point. Obviously, this is a very fantastic way to showcase how things have changed over a period of time, and what are the dramatic points in history. Now, we don't usually have such data in business situations. You don't have data from 1780 to 2015 unless you are running a really old company like Citibank or something like that. So more from an information analysis and presentation point of view, the issue that we analysts deal with is data for the last couple of years, and then we want to visualize and see how things have changed over a period of time. So I'm going to showcase a similar example but with a different type of data set, show you how you can construct these kind of charts. The only missing part of that puzzle that I'm going to show you is how to animate it. Now you could technically create such animations, that is the line starting from here and growing like that in Excel, but that would require a bit of VBA. And in my opinion, the animation is really an eye candy here. It's not really helping us discover what's happening. It's more for us to kind of sprinkle a bit of extra makeup on top of already beautiful and powerful chart. So I'm going to show you how to create the chart. I'm going to leave the animation part as a puzzle to you. Go ahead and try to figure it out. You could obviously come up with some really simple VBA script that will kind of automate this whole thing and create an animation for us. So let's jump into the workbook. This is a similar story but with the narrative of market share. Imagine you run a company that operates in 7 different product categories, and you have been in operations since April 2001, or maybe sometime later than something like January 2002. And from that point we are running operations, and we have been monitoring the market share that each of these product categories that we have. For example, category 1, when we launched, we obviously have 0% market share, but after an year or two we climbed up to 1% market share because we have done effective marketing and kind of gained place in our customers' hearts. So like that, you could see the story of how various categories have changed. The additional thing that I have added here is a slicer, so you could actually select any one category and that would get highlighted, so you could actually focus on that category in relation to rest of the narrative and see the picture. For the selected category, the summary is shown on the top that says, for example, category 7 is 4.5% market share in January 2015, whereas category 1 is 18.2% market share in January 2013. That's because we don't have data for the latest month. The data was captured as on Jan 2013. That was the last data point we had, and after that it is assumed to be flat. So this is a chart. Now let me show you the kind of input data that you would have for this kind of a thing. You would have month and year combinations here. You could have any month and year as long as they are in a chronological order. I just put some random dates of Jan and July for each of the years, and you would enter a number. Okay, when you start the operations, you have 0% market share. The next time we measured was in 2004. We had 1.7. So any significant changes will be marked. If there is a blank, we assume that same share continues on those dates as well. This will kind of reduce the amount of numbers we have to key in. Okay, so given this kind of a picture, obviously category 1 was the first category that we launched, so that has all the data, whereas category 2 was not even launched until July 2004, so we don't have any data prior to that. So all these prior cells are assumed to be blank. Now given this, how do you make that chart? If you just select this much data, okay, that's my month and category, and we go to insert a scatter plot of that, you would get something like this. So the jumps from 0 to 1.7 are missing, but from 1.7 to 2.8 you would see a sloped line. What we would expect to see is more of a L-shaped or inverted L-shaped lines, that is more like steps climbing, because that's what we are visualizing as the change here. Okay, obviously the change from 1.7% to 2.8 won't be like an abrupt change, that is before this month we had 1.7 and suddenly we now have 2.8. It would be more gradual for numbers like this, but purely from a presentation point of view, because these are important milestones in the history of our story of change, the step fashion makes a lot of sense, and that kind of aligns with the kind of picture that Bloomberg people have created also. So now I'm going to show you what kind of a chart will give you that that kind of a step picture. Let me just delete this. First I will show you how to solve the step mystery. Let me insert a blank sheet here and then say X and Y. X represents horizontal axis and Y represents vertical axis. You might notice that I'm a little slow with these videos. That's because I didn't bring my mic stand from India. I just got my mic, so I'm holding mic with my left hand and trying to type as well as control mouse with right hand. So you know, you could do it a lot faster. So we have X and Y, and then so for the point 1 we have 0%, and then for point 2 we have 3%. Now if you just create a scatter plot from this information alone, you would get a something like that. Okay, this is the accurate representation of that data, but the only thing is it is showing from 1 to 2 we had an abrupt we had a slopey jump. What we would like to see is like this. So from 1 to 2 we want to see a line that goes vertical and then horizontal. To do that, what you would do is, instead of that data, we recreate a new data set that has this new picture. So we have 1 and 2. Okay, and then we have 0% here, we have 0% here as well. Oh sorry, we have 3% here, and then we have 3% here. So once we have that data, we could select that and we could insert a scatter plot from that, and that'll give me that kind of a step fashion. Okay, so what we need to do is we need a mechanism to take this original data and remap it like this. Obviously you don't have to do all the typing yourself. You could figure out some sort of formulas that can take original data and create a remapped version. In the original data we had 2 data points or 2 line items. In the new data set we have 3. So the relationship between this and that is, if the original has 2, the new data set will have 2 times the original data minus 1. So that's going to give me 3. So if the original data has 27 row items, the new data set will have 53, which is 27 times 2, 54, minus 1, 53. Now that's the key point to keep in mind. It's not exactly double, it's minus 1. Okay, so what I have done is I took my original data, and we notice that there are 27 months of data here. I selected the label as well, so you could see 28 minus 1 because the label is selected, so 27. So we have 27 months of data, and now if I go here, what I have done is I have typed running numbers up to 53. This is because 27 times 2 minus 1 is 53. Now you could automate that step also, so that if you have 54 months of data, this will automatically generate up to 107. But just to keep things simple, I just assumed that we have 27 and I typed 53 running numbers 1 to 53, and then using a bit of index and index formulas, I go and take the dates. This thing is named as dates so that we could easily refer to it in our formulas. Take the number, divide it by 2 plus 1 so that we could get those values. So the Jan is repeated there, and June, like that. Okay, so we have our month and date combinations fetched. What is the categories 1 value? Well, this would be, there are 2 puzzles to solve here. The first puzzle is, if there is a blank, we have to assume it's the same value as above. Okay, so that's the first puzzle to solve. The second puzzle to solve is, if we are we need to repeat the value. So that's the second puzzle. That is, here we are repeating 3% 2 times, whereas here it is only printed once. Okay, so the repetition needs to happen. Likewise, the values, wherever they are missing, we need to go back and get the prior value. So this is where we are using a combination of different techniques. Now it would be a little tricky for me to explain this formula right away in this video. I would imagine that is something that you can learn on your own. But let me first show you how we could get the latest value. Okay. So let's say I'm looking up here and get the corresponding value for January 2004. Now if I do a simple VLOOKUP, I'm going to get blank because this value is nothing. Instead, what I need to do is I need to get that entire range and then get the last non-blank value. So when I'm here, I get 1.7%, but when I'm here, I'll get 0% because these are all blank. That should be 0. This would become more relevant when you have values like this. If you are looking for January 2008 value, you shouldn't get blank. You should get 11.5%, which is the correct value. So this is same as the problem of how to find the last non-blank value in a list. This can be solved by assuming that we have some values in a blank sheet like this. So we have 0, then 1, 2, 4, 6, 7, and 10. And now if I want to know what is the last non-blank value in this range, okay, and I select this up to that much and then call this as range. And I want to know within this range what is the last non-blank value, which should be 10. You could write a VLOOKUP formula that looks like this: VLOOKUP, and look up for a value that is extremely high. For example, in our range we have up to 10, so I'm saying look up 99, which doesn't exist in the range, and get me the value back from the same column, so 1, but do an approximate match that is true. So usually we look up formulas with false at the end because we want exact match. In this case we want approximate match, and this will give you 10. So if you come back at some point of time and you write one more value like 11, that's going to work. Likewise, if you delete a couple of values, it's going to work seamlessly. Okay, so this is the basic technique wherein we look up for a very high value that is not in our range and do an approximate lookup, so that VLOOKUP goes down and it stops at the last value and gives us that. When we don't know what is the range of our data, we usually write the number that is equivalent to the theoretical maximum value Excel can have, which is I think 1e99 or something like that. Okay, so that is 10 to the power of 99. Well, we don't need to go that far. We just need to see that all of these are percentages, so a typical value like 99 should suffice. So what I'm doing here is I'm writing a VLOOKUP of 99, but the range is dynamic. That is, the range should vary. If I'm looking for January 2002, I just need to look here. If I'm looking for January 2004, I need to look from here to here. If I'm looking for January 2008, I need to look from that point to this point. So the starting point is always here, C23 for category 1, but the ending point could be 35 or 38 or 40. We can't keep a relative reference there because for each month we have 2 corresponding rows in our calculation table. So for that reason, I'm using an offset formula to dynamically go to my corresponding row of the month and generating this range. Now this is slightly advanced, so if you don't understand, try to imagine having some sort of a mechanism that will expand your range dynamically, or do it in 2 steps. Here I'm trying to do everything in 1 step just so that the formulas and calculations look a little tidy. So we have, you are looking up for a very high theoretical value like 99 in a dynamic range and doing an approximate match. This will give us the 0%. Wherever the values are blank, it will also give the 0%. So we get these values for category 1, because these references are always anchored to row number 23, but the column is dynamic, that is, it is relative. When I drag this formula sideways, it will give me the corresponding values for category 2, 3, 4, 5 and 7. Right, once we have this data, you could select both of them and create a line chart or a scatter plot line chart that will create that kind of a stepwise illusion as shown here. So we create a stepwise chart that has 7 kind of steps, one for each category. But what about the selected category in slicer? Well, that's simple. What we do is set up the category names in a range like this, and insert a pivot table from that range alone and add a slicer to it, so that you have a harvester pivot, which is basically a pivot table. Purely use it to understand what is selected in the slicer. So we add the category to row label area as well as a slicer, and that's telling me that right now category 1 is selected. What happens when you select a different category? Very simple. If you go to your chart and click on another category like category 4, your pivot table is going to say category 4. Okay, based on that, we also generate another set of values for highlighted region, which is nothing but a copy of your original category values. Okay, so that's going to show me those values. Once all of this setup is done, we add all of that data to the scatter plot, select the highlight series and make sure that's in a bright red color or in a different contrast color so that it stands out. We place the slicer adjacent to this chart so that when you click on something, that category gets highlighted. Just so that we could add some additional insights, what I have done is I have created a text box that shows me for the selected category what was the latest percentage value in the latest month that for which we have data. So that kind of gives me some additional insight. Now you could go ahead and build some more on top of this. For example, you could do an animated version of it, that is upon slicer selection we could animate the highlight chart, or even do something else that is on top of it. But in general, the stepwise fashion is a really clever and really simple metaphor for change and progress, because when we look at a bunch of stairs or steps, we naturally associate that with progress. And in this case, where our narrative seems to be how our market share is changing, how we have progressed from 0 to 20% or 25% of the market share, that is what we have today. And this is a great way to depict that story. A couple of other scenarios where this kind of a chart can be used is, for example, if you're communicating, let's say you handle a project for deploying some sort of an IT solution, technology solution, and usually when you have a technology project, there is a stage in the technology projects called as testing, where people go and fix all the bugs and mistakes in the programs. And usually there are multiple modules, and the modules are developed, modules as in individual portions of the project that are developed at separate parts of time, and the testing also happens separately. So you could show the number of bugs and how many bugs are fixed in this kind of a chart as well. Likewise, you could show in a project progress what kind of milestones we are reaching, how much percentage of work is done, or even fundraising campaigns, or anything where change happens naturally and you want to visualize that change, understand where the steep climbs are, what was the trigger behind it, and narrate all of that story in a powerful medium without confusing or adding too many dimensions to your chart. I think this is a powerful way to depict that. So go ahead and try this chart. Go ahead and download the workbook. There is a copy of this workbook available, unlocked and available for you to completely play with, edit and examine each and every aspect of it at chendu.org. I'll place a link to that in the YouTube description of this video so that you could get that. So I hope you enjoyed this technique. It has been a really fun chart to create, and now since I'm on a vacation / work in Melbourne, I don't really want to take too much time talking to you. Thank you so much for listening. I hope you enjoyed this video. If you like it, do drop us a comment or subscribe to our channel. Thank you so much, and I'll see you again soon. Bye bye.